binomial theorem, and okay, the binomial theorem. And this is the purpose of the binomial theorem is that if you're given an equation in a plus b to the n power, and you wanted to find, say, the sixth term in that expansion, you would use the binomial theorem to do so. Most of the time with expansion, you can use the Pascal's triangle like we've already covered. But if you want to find a specific term, that's why you would use this. So I just want to give you an idea of what this looks like before we talk about how to use it. So if I were to ever try to find, I just had a very abstract, okay, and I didn't know what I was looking for. So this is going to be a formula. Binomial theorem says that if I were to expand a plus b to the n, again, abstract, we're talking about n terms, okay, we don't know how many. The first term is going to be a to the n, and you already know that. The next term, the coefficient on that term, is going to be n choose 1. Okay, this is why we did that mini lesson on combinations. Coefficients of that, a is n minus 1, b is just b. Then we're going to just do a dot 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 here because we're going to keep going and we want to see what's going on in the middle of my expansion. So another term is going to be n choose r. Okay, r is just being the number that we choose. A to the n minus r, b to the r. So this term that we're looking at, n choose r, is when the exponent, it's the number of the exponent on the b. It's not the r term. Okay, it's the exponent on the b. It's actually the r plus 1 term. Okay, and then what happens when we go all the way to the end? We go plus dot dot dot, and our very last term is going to be b to the n. So again, very abstract. This is just something so you can see what it looks like. Another way to write this, okay, is a plus b to the n equals the sum. You remember seeing this symbol? Okay, the sum of r equals 0. This is why this term right here is r. It's the r plus 1 term, is because r starts at 0, not at 1. So it's r to the 0 to n of n choose r, a to the n minus r, b to the r. So again, abstract, this is just how you would write it if you were looking at it from an abstract point of view. Now, what we want to use it for is if we're looking for a specific term inside an expansion. So I want the 8th term, I want the 9th term, I want the 5th term. Okay? So the term that we're looking for is always r plus 1 because the first term is actually the second thing that you will see because we start with the 0 term. So it's always t equals r, t to the r plus 1 equals n choose r, a to the n minus r, b to the r. So this is the one I'm looking for. So this formula is one that you will need to use. I'll write this down some more because this is what you will use on the homework. So for example, let's say I wanted to find the 7th term of this binomial expansion, 3x minus 4 over x squared to the 14th power. Okay? So let's just label all of our pieces because we're going to take this and we're going to plug it into, we're going to take this equation and we're going to plug it into this formula. So let's label all of our pieces. N is 14, R is 6, okay? Think about this, okay? R is always going to be 1 less than the term that we're looking for. So we're going to, R plus 1 is 7. Just think about it that way. Okay, A is 3x, and B is negative 4 over x squared. Okay, so I'm going to see if I can scroll. I don't think I can scroll down. I'm going to try though. Just move up a little bit. There we go. Okay, so let's plug it into the formula. 14, choose 6, A, oops, not A, I'm plugging all the numbers in. 3x to the n minus r, so 14 minus 6. Okay. And then negative 4 over x squared to the 6th power. All right, now, I want you to notice something. It's on your homework tonight, and this is really actually kind of cool, is it asks you to not simplify. I want you to leave it in this form. That's as far as we go. We don't simplify, that's it. Okay? So on all of your homework tonight, I think all of it is, none of it asks you to simplify. So that's example 1. The other example that we need to go over looks like this. So it gives me binomial expansion again. Oops, not squared. Sorry, I wrote my example down. 1 over x, just x, to the 12th power. Okay? And it wants the first 3 terms. So it wants t1, t2, and t3. The first 3 terms. Keep in mind, it asks for the first 3 terms, but this is actually 0, 1, and 2. So it's t1, t2, and t3. And then it asks for the last 2 terms. And I want you to think about this t12 and t13. Because there are actually the 13. When we think about it this way, because this t1 is the 0th term, t13 is the 12th term. So, and again, no simplifying. We're just going to plug in. So this is 12, choose 0, okay, 2 to the x to the 12th power. Okay, because 12 minus 0 is that 1 over x to the 0 power. Okay, you could write this as just 2 to the x to the 12th, but if we're trying to see what the formula looks like, you can leave it like that. Okay, t2, 12, choose 1. Remember that it's r, this is r plus 1, so 2 is r plus 1, the 1 is r. Okay. 2 to the x, the 12 minus 1, 1 over x to the 1. Okay, t3, 12, choose 2. 2 to the x, the 12 minus 2, 1 over x squared. So that's the first 3. Now let's look at the last 2. t12 is going to be 12, choose 11. 2 to the x to the 12 minus 11. And 1 over x to the 11th. And then the last one, 12, choose 12. 2 to the x to the 12th. 1 over x to the 0. Okay, if you choose to simplify a little bit, that's fine. For example, right here where I have 12 minus 1, I could write that as 11 instead. Same thing here, like where I have a 0 power, I don't necessarily have to write that. I could just leave it off because anything in 0 power is 1. But for the most part, do not simplify. I think that's it.